Welcome to the last part of metals. So far, we have looked at characteristics of metals. We also looked at the reactivity series, recycling of metals. In the last video, we started or we took a look at extraction of metals, two metals to be specific, which are aluminium and zinc. In this video, we're going to continue with extraction of metals. We're going to take a look at extraction of iron and extraction of copper. Then we end this topic and this video with alloys. Let's get started. We're going to start with extraction of iron. This extraction process is the most ingenious method of extracting metals I know. So, iron is extracted from its ore called hematite by the reduction method in the blast furnace. So the ore that is used in this extraction is called hematite. The method they use is reduction, not electrolysis, not thermal decomposition. And the apparatus is called the blast furnace. So here is how the blast furnace looks like. So to understand how the various components of the blast furnace work, we're going to start with the top. So the three raw materials that are used in this process are combined together to form what is called charge. This charge is made of three different raw materials, like I said. The first is the hematite, which is the iron ore. The second is carbon, which is coke. The third is limestone. So limestone is a compound that has got a specific role in this reaction. Limestone, its chemical name is calcium carbonate. So when the three are combined in here, they are roasted in here. So when they are roasted in here, what happens is the coke, which is carbon, is going to combine with oxygen. That combination of coke and oxygen is an exothermic reaction, meaning that it releases heat to the external environment. Okay, so that will help in keeping the temperature very high in here. So once that is happening, so hot air is blasted in here. So hot air will be blasted in here, which of course is going to constitute, or it's going to have carbon dioxide. This carbon dioxide is going to rise up to the charge. This carbon dioxide is further going to react with the coke. So once this carbon dioxide reacts more with the coke, then carbon monoxide is going to be formed. Okay, so once we have this carbon monoxide now reacts with iron ore, which is hematite. Carbon monoxide is a reducing agent, meaning that it helps, or in its presence, some other compounds lose oxygen. That's what it means by being a reducing agent. So carbon monoxide, which has been formed by the reaction of carbon and carbon dioxide, is a reducing agent. It's going to remove oxygen from other substances. Therefore, this carbon monoxide reacts with, like I said, hematite, removing the oxygen from the hematite, such that we end up with pure iron, which is going to be down here, and it can be collected here. Okay, so we have seen the role of coke, which is of course first to increase the temperature when it reacts with oxygen, second to react with carbon dioxide to form carbon monoxide, which is going to remove oxygen from hematite. What about limestone? What is it doing? So when the temperature is rising, and of course, why do we need the temperature to rise? So when the temperature is rising, limestone is broken into calcium oxide and carbon dioxide. Remember, limestone is calcium carbonate. So once it's heated, it breaks to calcium oxide and carbon dioxide. This calcium oxide acts as a flux. The meaning of flux is something that is added to something that is that has been melted so that it can flow easily. In other words, the way to see it is this calcium oxide is going to combine with impurities, removing impurities from the melted iron. Those impurities are going to float on top of the melted iron, and they are called slag. So this slag can be removed also. So of course, let's just go through everything that I've said step by step, looking at each and every equation that occurs at each and every stage. So I've talked about charge, which is made of three raw materials mixed together. The first being the iron ore, which the chief is hematite. The chemical formula is iron 2O3. The second raw material is limestone, which is calcium carbonate. The third is coke, which is just pure carbon. So this charge is crushed and placed into the top of the blast furnace. It is then roasted in air. By roasting, it means it is heated air. So the chemical reactions that occur, the first is the coke, which is carbon, reacts with oxygen in hot air to form carbon dioxide. The reaction raises the temperature in the blast furnace. Like I said, it is exothermic. So carbon reacts with oxygen to form carbon dioxide, in the process increasing the temperature of the blast furnace. Then hot air is forced into the bottom of the blast furnace. Of course, this is oxygen, and of course there will be carbon dioxide. It will force the carbon dioxide, which is inside the blast furnace, to move up. This carbon dioxide, when it moves up, it reacts with more coke to form carbon monoxide. So one key point we can get here, not exactly a key point, but a side note, is carbon, which is called a reducing agent in this, because it reduces carbon dioxide to carbon monoxide. Okay, so as you are going to see, the carbon is going to reduce the carbon dioxide to carbon monoxide once the carbon dioxide reaches where the three are, where the charge is. So when it reaches there, actually this is the reaction that occurs. Carbon reacts with carbon dioxide. The carbon dioxide that has been pushed up by the air that has been blown on the bottom. So this carbon dioxide reacts with carbon to form carbon monoxide. The fact that one oxygen atom is removed to combine with carbon means carbon is a reducing agent. A reducing agent is that which is oxygen from something else. So this carbon monoxide that is formed reacts with iron oxide to form liquid iron and carbon dioxide. So in this reaction now, where carbon monoxide reacts with iron oxide, carbon monoxide gas is a reducing agent because it reduces the iron oxide to iron. In short, this is where reduction occurs. This is where the removal of oxygen from the ore occurs. So the iron oxide, which has oxygen atoms, the oxygen have been removed by carbon monoxide. So this was the entire purpose of everything that we have done so far. So of this reaction, iron reacts with carbon monoxide to form iron and carbon dioxide. This iron then trickles to the bottom of the furnace where it is tapped off. Then the limestone now, which we haven't talked about, decomposes to form calcium oxide and carbon dioxide when the temperature is rising. So the calcium carbonate is decomposed to form calcium oxide and carbon dioxide. So this fact here, remember what we talked about thermal decomposition. We said for group 2 elements, when heated, the carbonates, when they are heated, they form oxide. So this is what has happened here. So the purpose of limestone is to act as a flux. So like I said, a flux is just added to increase the fluidity or the ability to flow of that molten iron. But in essence, it reacts with impurities, removing the impurities from the molten iron. So the calcium oxide now, like I said, reacts with impurities. The main impurity is silicon dioxide, which is just sand. So calcium oxide reacts with sand to form calcium silicate, which is also called slag. So this slag runs down the furnace and falls on the iron, and this brings also another advantage. So once the slag is on top of the iron, it prevents the iron from being oxidized by the incoming oxygen. So as the reaction is proceeding, on top of the furnace there is oxygen. So once the iron is covered by slag, the oxygen cannot reach the iron, meaning that the iron is going to stay pure. So that's one advantage that slag adds. That's, like I said, this is the most ingenious because there are different processes but all leading to one goal. Okay, so calcium oxide reacts with sand, it forms slag. In the process, it has purified the ion. Then this slag also covers the ion such that oxygen cannot reach the ion, to meaning that a reaction or a process where ion reacts with oxygen is prevented. Then slag can be tapped off. So this is the reaction of calcium oxide with impurities. So calcium oxide reacts with silicon dioxide to form calcium silicate. So in summary, calcium oxide is used to remove impurities such as silicon dioxide, like I've said. Now, this slag has got some special uses. Like I said, this is the most ingenious method of extracting metals. One of the uses is it is used in the manufacture of cement. Second, it is used for making rods. Now, one thing to note is the raw iron obtained in this process is called cast iron or pig iron. Despite not having silicon dioxide, it contains other impurities. Okay? Despite being able to remove silicon dioxide by the blast furnace, it contains other impurities. So depending on the usage, you can use it in its form as a cast iron, or you can do further processing to turn it into a different type of iron. The point is, it still contains impurities. Though silicon dioxide has been removed, sand has been removed, it doesn't have sand. The purest form of iron is called wrought iron, which you get after the pig iron or the cast iron has undergone other processes. Next, we look at copper. Copper, just like zinc, has more than one ore. The ores of copper, the first one, Monoxide, whose chemical name is copper 2 carbonate. The formula is this. The second is called copper pyrites. The chemical name is copper 1 sulfide. The formula is this. So I'm sure there's a mistake. It's not supposed to be oxide, it's supposed to be sulfur. So how do we extract copper? Copper is extracted from copper 1 sulfide by thermal decomposition. This is usually done in the presence of oxygen. The copper 1 sulfide is reduced to copper by heating in a controlled supply of air. Okay, so what is obtained in this process is an impure copper called blister copper. So when we do this thermal decomposition, what we get is an impure copper called blister copper. So unlike iron, which we did not discuss the further processing on how we can get wrought iron from pig or cast iron, for copper we're going to discuss how to purify it. So the process for extraction of copper is to get copper, you react it with oxygen. So the reaction is the thermal decomposition. This is burning. Something when it's reacting with oxygen, it's burning. It's called combustion, or in this case, it's thermal decomposition because we're breaking down this. So once it reacts with oxygen, copper is going to be formed and sulfur dioxide. So how do we purify copper? So we use electrolysis to purify copper. So copper contains some impurities such as silver, gold, and cobalt. Okay, so these have to be removed. So this is the apparatus, the electrolysis apparatus. So here are things to note. The anode in this apparatus is made of the impure copper which we are planning to purify. So we get that copper which we have gotten from that thermal decomposition, we use it as an anode. Then the cathode, we need a pure copper. Okay, then the electrolyte that is used is a solution called copper 2 sulfate solution. So once the circuit is powered, what's going to happen is the impure copper here is going to separate, like the copper is going to separate from the impurities. So once the copper separates from the impurities, it's going to be a copper ion. So these copper 2 ions actually are going or need electrons. the copper 2 ions need electrons for them to be stable because they are ions. So they will be moving looking for electrons. And we know where we have lots of electrons is at the cathode. Cathode, the negative electrode, has lots of electrons. So the impure copper, the copper 2 ions are going to move to the cathode to get 2 electrons to become copper. So what's going to be happening is, as the copper ions are leaving this anode, this one is going to be reducing in size, and as they are getting electrons, they become part of this pure copper. So these are going to the cathode is going to be increasing in size. So this will reduce till we remain with impurities. Actually, the impurities will be falling off here to form sludge. This sludge, which might contain gold, silver. So this is the one we're going to throw at Black Mountain so that those who go and pick do the needful. But this is how copper is purified. So in short, at the anode, pure copper from pure anode goes into solution, reducing the size of the anode. So copper becomes copper ion and goes to the cathode to get 2 electrons. So impurities called anodes, impurities called anode sludge fall to the bottom of the cell. The anode sludge may contain valuable metals such as silver and gold, which we can throw at Black Mountain. At the anode, copper ions accept 2 electrons each and are deposited as pure copper metal on the electrode, which increases in size, meaning the cathode here. So, sorry, supposed to be cathode. At the cathode, copper ions accept 2 electrons each and are deposited as pure copper metal on the electrode, which increases in size. So this is what happens at the cathode. At the anode, copper just breaks to have the to form copper ions. Then at the anode, the electrons are gained to form copper, to form back the pure copper. So what are some uses of copper? First, it is used in making electric cables because it is a good conductor of it, just like aluminium. It is used in making alloys, e.g. bronze and brass, just like aluminium. It is used in making coils. It is also used in making ornaments in jewelry industries, e.g. coins, necklaces, and rings. Also, it is used in making cooking utensils, just like aluminium, and boilers, since it is a good conductor of heat. Finally, we look at alloys. An alloy is a mixture of 2 or more metals, or a metal with a non-metal. When we get the metal and the other metal, mix them so that we have a metal, or we have something that is a blend of properties of both metals. It's called an alloy. We can also have a metal and a non-metal. So the combination of alloys is not a chemical combination, it's a physical combination. Alloying a metal is one way of increasing its strength. So how are alloys prepared? First, the mixture is usually heated under controlled temperature. Once it has melted, it is in the molten state. The molten mixture is then allowed to cool and solidify. That's how alloys are made. So what are some of the advantages of alloys? The first is they are flexible in use because they have different properties that cater for different ranges of metals, so they are flexible in use. 2, they usually have improved appearance. They are durable and reliable. They also have an increased resistance to corrosion. So here are some alloys, and here we have alloys, then here we have their constituents, and then the percentage, like each element that makes up a given alloy, what percentage of it is in the alloy. Then of course the particular properties of this alloy and the typical uses of the alloy. So we have brass, which is made of copper and zinc. It has 70% copper and 30% zinc. It is not necessary to master the percentages. Yeah, just know that brass is made of copper and zinc, bronze, this and that. So the particular properties of this alloy is it is harder than pure copper, and it also has a resistance to corrosion. So zinc, when combined with copper, brings some hardness to copper and also some resistance to corrosion. The typical use of brass is it is used to make musical instruments. Then we have also bronze, that is made of copper and tin, and it is 90% copper, 10% tin, and the properties, it is harder than pure copper. Because of this, it is used to make trophies and medallions. It is also shiny, it has a nice color. Then we also have melt steel, which is made of iron and carbon. So we defined an alloy as something that is made of which is a physical mixture of two or more metals, but we also defined it to be a mixture of a metal and a non-metal, and this is a good example: iron and carbon. So melt steel was 99.7% iron and 0.3% carbon, so it's stronger and harder than pure iron. It is used to make bridges, and it is used to make boring tools. Then we have this famous one, stainless steel, which is made of iron, chromium, and nickel. So it has 70% iron, 20% chromium, and 10% nickel. So the particular properties, it is harder than pure iron and does not rust. It is used to make things like razor blades, knives, because of its ability not to rust. Then we have solder, which is made of tin and lead. Sorry, I did not show lead here. So it is 50% tin and 50% lead. It has a lower melting point. Because it has a lower melting point, it is used for soldering. So this marks the end of this topic. Hope you have learned a thing or two. Otherwise, happy